All right, well, it's go time. Welcome, everyone. If you don't know who I am Steve Lorello, and I am a developer advocate at Redis. And for those of you who are here, I really appreciate it, because we are the last slot of the day. And for posterity, we just had a minor evacuation that lasted about an hour of the venue. So I really appreciate everyone who came back to come to this talk. And today, I'm going to be talking about indexing, searching, and aggregation in Redis using RediSearch and .NET. So before I start any talk, I usually like to go over just a little bit of an agenda of what I'm going to be talking about that day. We're going to start off with an introduction to what Redis is. Then we're going to talk a little bit about the different data structures that make up Redis. Then we'll talk about just broadly secondary indexing. And then we're going to look at two modes of secondary indexing in Redis, with any Redis and with Redis Search. Then we'll be talking about writing queries with Redis Search, and then writing aggregations with Redis Search. And at the end, I'm going to do a little demo with basically from an empty console, empty file, and I'm just going to show you all how to sort of get up and running with a new library for Redis Search that I wrote called Redis OM NET. So what is Redis? Well, you know what? I'll just stop right here. Who in this room has heard of Redis before? So everyone here has heard of Redis. Who in here has used Redis for anything but a cache? Okay, so one person, and full disclosure, the one person who raises their hand, I am a coworker of. So one person has used it as anything but a cache. Well, really what it is, it's a NoSQL database. It's a NoSQL database that's stored completely in memory. So like the entire database is stored in memory. There's durability, things that go along with it where you can offload the data to a disk, so if there's a disaster, you can recover it. But in general, it's in memory. Fundamentally, what it is a key value store, but it's also multimodal, and we'll get over the different modals of Redis when we talk about the data structures a little bit later. And the two things that really stand out about Redis, to me at least, is that it's fast and that it's really simple. And because of those last two things, it's actually extremely popular. And I mean, everyone here has heard of Redis, and I think a fair number of you have used it. And it's actually the most beloved database by developers according to the Stack Overflow survey, and I think it's been like that for a few years running now. So Redis is a composition of different data structures. There's 5 that are really important to talk about in context of this talk. There's strings, sets, sorted sets, hashes, and JSON. And there's more than this, but these are the 5 that are really important in context for us. So strings, they are a very simple data structure. They're a single key that retrieves a single value in Redis. And that value can be further encoded to numerics or strings, and it's the most basic data type in Redis. So who here has used Redis? So of the 4 people who have used Redis, one of them has used probably anything beyond a string. They're the simplest and most commonly used data type in Redis. And so many users really never get beyond this data type. So basically, to use a string in Redis, you just have to set it, like set foo bar, and you can get it. You can get foo, and that'll retrieve it from you. Actually, while we're doing this, I'll open up a terminal, and I'm going to increase the size of that so people can actually see it. And do I have Redis running? I do. So if I want to set a string in Redis, I just do a set foo bar, and then I can just get that string. It just stores a simple string at a particular value at a particular key in Redis. You could do things like appending to foo baz, and get foo now returns bar baz. Bar baz. So those are strings. They're really the simplest data type in Redis. Sets are like a mathematical set of strings. It's just a set of unordered strings with no duplication allowed, and set operations allow you to combine sets together to do different things. So in here, this example right here, we have sad person colon name colon Steve, and I'm inserting person colon 1. And so like with sets, I can do sad person colon name colon Steve, person 1, and I can do sad person colon name colon guy and do person 2. And then I can do something like a S union person colon name colon Steve, person colon name colon guy. And that's actually going to return to me the union of those two sets, which is person colon 1 and person colon 2. And you can use these different set operations to do this. The supported set operations are in intersections, differences, and unions. Sorted sets are kind of like your sets, except they're actually ordered. So you provide a score for every member of the set that you're inserting. So the example I give here is zrange, or not zrange, is an age sorted set. So I could do a z add person colon age 32, and then add person colon 1, and then 45 for person 2. And this allows you to still not duplicate members, so you can update them. And you can order them either by score, by rank, or lexicographically. So if I went into Redis and I did a z add person colon age, and I added 32 person colon 1 and 45 person, not 35, 45 person colon 2. Make that a little bit bigger. I can then do a zrange person colon age. And if I go from 0 to -1, I'm going to get both people. If I do by score, so if I do 30 to 35 and I say by score, that's just going to give me person colon 1 whose age is 32. And I can do that with scores. And it'll provide me the score for that person. So it'll give me their ID and their age back. Then we have Redis hashes. And what Redis hashes are, they're basically a dictionary. They're a dictionary of strings. And basically, they're a set of field values that you store in this Redis hash object. And they're great for if you want to map basically very flat objects in Redis. So in this case, we're storing a person in here, person colon 1, whose age is 32 and their first name is Steve. And you can do all sorts of neat things with these now. So I can do an age set person colon 1, first name or name is Steve, age is 32, and I can do an hget person colon 1 name. I could just get their name back, which is Steve, or I can do that with age. Or if I want to get the entirety of person colon 1 back, I can just do an hget all, and I get the fields in their values back. So this is interesting because it allows us to actually start storing objects in Redis. Then we get to JSON, which is similar conceptually to a hash, but you're storing JSON objects in Redis. And the really nice thing about storing JSON in Redis is that you can access the things within it and you can update the things within it via JSON path. So for example, right here, I'm doing JSON.set person colon 1, and I'm passing in this JSON object, which is just me, first name Steve, age 32. And you can actually update and query this by a path. The only trick with this is that you have to use a Redis module, which is an extension of Redis. And actually, the company I work for, Redis, produces a bunch of these, and they're available under a source available license that you can use them in your applications. Basically, if you want to use them in your app, if you wanted to manage your own servers and stuff like that, you're free to use it. Otherwise, you basically have to get it from us. But yeah, so just to give you a quick demo of what this looks like, I'm just going to flush a database, and I'll do a JSON.set person colon 1 this time with name is Steve, and age is 32. Oh, I need to pass the path in, which can For the base, it's either a $sign or a period. And then I can just do a JSON get, person:1, and I can get whatever I'm looking for, so name. Whoops. I can get name, which is Steve, or I can get age, which is 32. And this allows you to build much richer objects that you can add to Redis now. And that actually brings us to really what the crux of this talk is meant to be, and that's finding things in Redis. So the trick with Redis is because it's a key value database fundamentally, you can't just search for things sort of out of the box with Redis. You can't just do like a select star from people where the first name is Steve. You can't do a select star from people where age is less than 35. It just isn't set up to work like that. The most efficient queries you can make are on the primary key, which in the example I've been showing you so far has been person:1, right? So if I wanted to find person:1, if I wanted to find anything in it, I can do a JSON.search, or not JSON.search, JSON.get person:1, and pass in the root path, which is a period or a $sign, and I can get the whole object. But I can't just look for all the people named Steve right out of the box here. So if I wanted to do this, I need to build a secondary index, which is just an efficient way to declare things within the primary index. And like I said, the primary index in Redis are its keys, right? So person:1 is the key. And the big difference between the secondary index and the primary index is that it has to be explicitly declared, and you had to separately maintain and update it. Now, this is what kind of secondary indices look like in any vanilla Redis instance that you might be working with. Basically, exact matches are either sorted or unsorted sets, if you want to do exact text matches. Exact numeric matches you can also do in sets. But if you want to sort things, or if you want to have any kind of order for things, you have to use sorted sets. And full text you also build off of using sorted sets. So these examples here are basically a sorted set on the right here, or just an unordered set on the left here. And as I was showing you before, you can basically add things to that. You can add things to them to actually build your index out. So you can store your data in a hash in any form of Redis. So, and I'll just retrieve that hset command I sent before. So I can store the data in a hash, and then for each, basically whatever you want your index name to be, field and value, you can create a set. So if I want to find all the people named Steve, I can do a sad person, which is my index name. Now colons are, the convention in Redis is that you use colons to separate things in your namespace. So person:name: Steve, I can add person:1, which when I want to find all the people named Steve, I can do a smembers person:1 name: Steve, and I can get all the people named Steve back, and then I can use that key to do an hgetAll of person:1. Oh, I think I spelled that wrong. Yeah, hgetAll person:1. And that'll get me that person back. So I can use these sets, and you can also use sorted sets to do this, to get these. And if you want to do more complex queries, use a different set combination operation that we were talking about before with S unions and S intersections and S differences. And you can basically build a conglomeration of different sets that you can combine together to get the data that you want. For numerics, you just store the sorted set. You store in a sorted set of just the field's name for the index that you're building, and you can basically store the scores for a particular field. And then you just use range queries like I showed you before to find all the relevant documents to whatever you're looking for. And you do the same thing where you just basically do an hgetAll to pull all the data out of it. Now, the pros of using this type of indexing Redis is that it can be done on any Redis database. You don't need any special modules or anything that you build out from it to do this. And it allows you to have total control over what you index and what you don't. And I kind of facetiously said in here it's really good for job security because these, when you're doing anything particularly complex, these get very difficult to maintain. And yeah, so any sort of data modeling becomes very complicated. And the biggest problem, at least in my opinion, is the fact that you can't really horizontally scale your database out after you build one of these indexes. Because essentially in Redis cluster, which is the horizontally scaled out version of Redis, you can't operate on different keys atomically with each other, because if one key is on one shard and another key is on another, so say your index is on one shard and your actual object's on another, when the object gets updated, you can't atomically go over to the database where your index is maintained and update the index. You have to do them separately. And this means that you have to make regular consistency updates throughout your cluster, which is a real pain in the butt to use. Or we can use Redis Search, which is the topic of this talk. So what is Redis Search? Well, Redis Search is a module of Redis that's maintained by us, Redis. It allows you to define a schema of an index and then have Redis basically take care of the indexing for you. You can basically automatically insert your data and Redis will automatically index your data for you. And it provides full text search capabilities. You can do geofiltering. You can index automatically across shards. And this is also available under that same source available license that I mentioned earlier. So to spin up an instance of Redis Search, you want to use the Redis stack Docker image. So basically you just run docker run -p 6379:6379 Redis/Redis stack, which is what I have running right now. Now, to create an index, you can create an index for either of those data types that I referred to earlier, a hash or JSON, and the indices may be declared on a particular prefix. So for example, if you just want to index people, you can index them by saying, oh, the prefix I want to use is person:, and that'll create the index for you on just those people. And indices contain a schema mapping fields to different types within the index, and there's 4 different index types. Tags, which are basically exact matches or faceted matches. Text, which allows you to do full text search. Numerics, which, index numbers. And geo, which allows you to index different places. For querying things in Redis, with Redis Search, you use the ft-search command. And the query syntax varies by data type. Tags, you can do field name, with braces, the search data that you're looking for. For text, you could do field name, search data, whatever the search data is. For geo, you can use a geo filter. There's also a new way to actually add the geo to your query. And for numerics, you basically use square braces to go from a lower to upper bound. So I'll just show you that real quick. So if I do an hset on add person:1, name is Steve, age is 32, I can now do a ft.create, which will create the index for me. I'll call it person IDX, and I will say that the schema for this, well, first I'll say prefix 1 person:, and I'll say that the schema for this is name, tag, age, numeric. And when I want to go do an ft.search, person IDX, I can do basically a query that says like name is Steve, and it'll find me all the people named Steve, and it'll return the whole document for me. If I flush the database again, and I do a JSON.set person:1 name is Steve, and I do that same ft.create command, but declare that it's going to go specifically on JSON, I can still do that same ft search command. Oh, hold on. I had to make a slight modification to the schema. Basically, I have to say what the path to the thing I'm indexing is. So $.name as name, and then I can do that kind of search, and it'll return to me the actual document, the whole JSON document in here. Or in this case, it's going to be the same, but I can do a return one name, and it'll just return the name for me. So it basically lets me like search for things, and you can do all sorts of neat things with this. So that brings us to aggregations, which are another feature of Redis Search, which allows you to query your data using that same syntax. But then you can actually build pipelines within your data to transform the data that you've received from Redis and do things like calculate sums or calculate averages or standard deviations. You can do all sorts of like string manipulations. You can change timestamps, a bunch of neat things. It also allows you to basically filter results based off of the results of your aggregations. The first type of thing that you can do in a aggregation is you run apply functions. So you could apply a function to your data. So for example, if you have an employee object that you have sales for, maybe like a sales adjustment for a region, you can just take those two values within Redis and combine them together in this pipeline and create a new sales adjusted result for you to access later down the pipeline or when you actually materialize your results. You could do a variety of different mathematical and string and timestamp functions on the data that you have stored in Redis using apply functions, and you can store the results of an apply function in the pipeline, and then you can use them further down the pipeline for things. So if I had a bunch of departments, and I wanted to combine them all together, or combine all the sales of all of my representatives together, but this sales adjustment thing, and I wanted to order my departments by the amount of sales that they had, I can do that using Redis Search and Aggregations. Group bys and reductions are sort of what you think they are. Records with like fields are grouped together, and then those group records can run different reduction functions to combine them. So for example, sums or standard deviations. And then group records can also be passed further down the pipeline. And that brings us to the actual code demo portion of this talk, and that's using Redis OM. So Redis OM, specifically the .NET version, is a library that I wrote for doing object mapping and creating these searches for you so you don't have to learn all this messy Redis search syntax. Basically, you can declare your index on objects. You can use a Fluent API that's based in Link to perform searches and aggregations for them. And you can do object mapping and other stuff using Redis OM. And there are other iterations of Redis OM for Node, Python, and JavaScript. So, clear, CD projects, Redis. So I'm just going to go kind of from jump here and do a .NET new -n test Redis OM. Oh, it probably would help if I specify what type. New console -n test Redis OM, CD into test Redis OM, and open this. And I'm going to open it up in Writer. Well, that's opening. Oh, that's just opening, that's fine. So now that this is open, I'm just going to run a .NET add package, redis.om, and that's going to install the Redis OM package locally here. And I'm just going to create that, you know what? I think I'm going to create that employee class I was talking about earlier. So I'll do a add class or interface employee. Now, an employee, let's give it some fields. I'll give it a name. I'll give them our employees' names. I'll do a prop. Let's do string department. Let's do a prop double sales and a prop double sales adjustment. And now with Redis OM, the things I need to do to basically declare what I want to index in here is I have to do an indexed, I have to add an indexed attribute above my fields, and I realize that probably some people might not be able to see this, so I'm going to zoom in a little bit. So I just have to give this indexed attribute up here, and I can make the things in here sortable or aggregatable by just setting them in here. So I'm going to make my names indexed. I'll make departments indexed. I'll make my sales indexed. I'll just make everything indexed, actually. And I spelled adjustment wrong, didn't I? And for my sales and sales adjustment, I think I'm going to want to make perform aggregations on these later, so I'm going to make them both aggregatable. So aggregatable is true. Aggregatable is true. Yeah. I'll use my departments too. Set those as aggregatable. In this whole employee class, I now want to basically declare that this employee class is going to be a quote-unquote document in Redis. And I'm going to give it an index name equals employee IDX. And the prefix that I'm going to use for all my employees is just going to be employee. So that's just going to be the prefix that it's going to use when it's creating these documents. And I can even give them IDs. So I'll say that this prop string ID is a Redis ID field. Now, when I go into program.cs, I basically am just going to have to initialize a Redis connection provider. So I'll call this provider a new Redis connection provider. And there's two different ways I could really initialize this. I could either initialize this with a connection multiplexer, which is the thing that most people use when they're using Redis is they use the stackexchange.redis library. And you can either initialize that yourself and pass it into here so you can reuse the same one throughout your app, or in this case, I'm just going to pass it a connection string, which is Redis :/ 6379, or :6379. And this connection string, Redis OM knows how to parse it and turn it into a connection for you, and it'll just basically use a connection multiplexer under the hood, in case anybody was wondering what library this is running on top of. And then, if I want to create my person index, all I have to do is say provider.connection.createIndex, and I can pass in my type, which is type of person. Or, it's not a person, is it? Employee. And then now that I have created the index, so if I run this, and I run the monitor back here, if I do a .NET run, you'll see it actually creates the index nicely for me, assuming that it didn't just completely error out, which it didn't. It had actually created an index for me because I'm setting this, because I didn't specify that this was a JSON index is creating on a hash, and it's creating this index with employee and the different fields in here that I declared for it to create it for. Now to actually start executing some queries on this, I need to pull a Redis collection out of this provider. So I'll say var collection equals provider dot Redis collection, and I'll pass in that, or I'll use the employee object as a generic for this. And now this collection, I can do a collection dot insert async, and I can start inserting people into this. So new employee, and I'll pass Steve, and see, name equals Steve. My department equals, I'll say EMEA sales or something. Even though I don't live in Europe, I'll say it's EMEA sales. My sales for the year, for the sake of argument, let's say I had a good year this year and I sold $10 million worth of stuff. I think that's 10 million. That's about 10 million, close enough. And I'll give myself a sales adjustment of maybe 0.8. Maybe it's a regional sales adjustment, and we just assume that the European market has more money, and we're going to, that's how we're going to evaluate our employees. And I can just await this. It'll insert it into Redis for me. So if I do a .NET run, you'll see that it created it created the index last time, but this time it's at that hset method with the employee, and employee is the prefix, and then I have this ULID right here, which is basically an orderable GUID. It's the ID that we chose to use. It binds that same GUID or ULID to the ID field in here, and it passes in the name of Steve, Department of EMEA Sales, blah, 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 blah. So it passes all of this in for me. But the neat thing is, now if I just wanted to find all the Steves in Redis, this is interesting. Hold on, I think Ryder's bugging out of me a little bit. That's really weird, because I put the new line in and it just like gave me a tab. Okay, so now if I want to find all the people named Steve in here, I can do a for each of our employees, employee where in collection.where name is equal to Steve, and I can even await that because that's actually an asynchronous collection. There's an async enumerable. So I can do this in an await, and I can do a console dot write line and pass in the employee dot name. And now if I do a .NET run in here, you'll see that, well, there's two Steves in here now because I inserted a second Steve. But if I came out of here, did a Redis CLI flush DB, and I ran this, I would get exactly one Steve in here. So I can do the same thing for other employees, say. Pass in Guy Royce. I'll just say Guy. Do Simon. And we'll put, say, Guy into American NA sales and Simon to APAC sales, and we start adding other people. Maybe like, oh, this is really zoomed out again, huh? Let's say Bob, Alice. Say APAC sales and EMEA sales again. And we'll just give them some other sales figures, so like maybe 500K or 5 million or something like that. We'll do something like this. And then I can find everybody who in here. So like I could do other things too. So like if I wanted to find all the places, all the employees whose sales were more than 5 million or something, x dot sales was greater than do that. Basically just say x dot sales is greater than that. .NET run. It'll print out all the people in here whose sales are greater than 5 million. I can also do greater than or equal to. You can combine different you can combine different things together too. Hold on. You know what I'm going to do actually at the end here? I'm going to do what you should never do with a Redis database, and I'm just going to call flushdb. Never put this in your app. Never put this in your app. I mean, if you don't care about as long as you don't care about your data, you can put this in your app. But if you care about your data, keep flushdb out of your app. But that basically all that's going to do is just every time it's going to flush the database for me at the end. So now I won't have duplicates this time. So like you can do this with numerics. You can combine different queries together. So if I want to find all the people who have sales greater than 5 million or whose name is Bob, I could do x.name equals Bob for some reason. You can do that too. Oh, that's an and, sorry. If I want to do an or, the and's not going to return anything because there are no Bobs who have sales greater than 5 million. I can do that. And so like Redis OM allows you to basically use this nice link interface to interact natively with Redis search the way you would think you would if you were a .NET developer. Yeah, so, but then if I wanted to put something like geodata in here, I could do that as well. So like geolocation data. So let's just find some sensible place on Google Maps. Well, where are we now? So if I just dropped a pin, what's our geolocation? All right, so I'll do text edit, and then I'll just put a bunch of points in here. Does this not allow me to zoom in? Zoom in. All right. There we go. So if I just want to open up a bunch of random places and I want to say, like maybe mess with a couple of numbers here and there. So 65 and 32 and 81, 82, or maybe this person is at 54. And of course we're in the UK, so everything is longitudinally very close, 0.135. So maybe I'll put someone at 1 and 2 and 3 and 4 and 5 and just gradually shoot ourselves. I think that's going west. That's going west, right? Now, I can basically declare this geotype in here. So I could do geolock. And I won't call this home because that's a little weird to put in the thing, but I'll say location. And then to index that, all I need to do is declare this as an index object in here. And then I can go into my program file and I can just start adding these locations. So location equals new geolock. And I actually need to put these in a different order because it expects it longitude, latitude. And that is a thing about Redis is that when you deal with geo coordinates in Redis, there's basically a geodata structure too, which is one of the data structures I didn't get to. But when you're dealing with geodata in Redis, one of the quirky things is that they want you to put everything in longitude and latitude. Even though if you're used to Google Maps, you're probably used to latitude, longitude. That's a little backwards, but it's okay. So new geolock, reverse these. That's going to be good enough for us. That's all we're going to do. So if I wanted to now start filtering things by their geolocation, I can start filtering employees by their geolocation. I can start doing that too, actually. So in here, if I said, instead of where, if I said .geofilter, I can pass in the part of the object that I want to geofilter. So x.location. So that has to be a geolock. And I pass in the longitude and latitude. So let's say the longitude is this number, and the latitude is this number. I could then put in a radius from the center, that center point that I want to measure out from. So let me say 10, and I could give it the unit too, which I'll say is miles. Then I can do a .NET run in here. I think it should just return to be the one record. So the only person that's within striking distance is Guy. Guy's up here, which is why the joke is funny, and he's a colleague of mine. So if I expanded it out to 50 miles, I get both of us. Like, we're both within 50 miles at that point. So you can basically build these nice little geofilters on top of everything else. And of course, I can also add where clauses in here too. So I can say x.firstname or x.name is equal to Steve. So just find all the Steves, because we don't care about the guys. And it'll allow me to filter down on that too. Now, with these queries as well, we can just like order things by different things that we've basically marked as sortable or aggregatable. So collection dot order by x dot sales. That might actually not actually have a, yeah, because that doesn't actually return an async quotable. So if I did that, and I printed out, let me just do some string interpolation here. It'll print out in descending order, basically the different sales that everyone had. I can also do that order by descending. It'll allow you to do that too. And the thing is that like this isn't happening in your app. So basically everything that happens before the for each starts to enumerate is executed on Redis. So if I went back into here and I ran a Redis CLI monitor, I did a .NET run, basically it's going to create this query for me that's going to actually sort it descending in a descending fashion, or if I change this to just order by, it'll sort it ascending. You'll see that changed to ascending. So the nice thing here is that like this really removes a lot of the abstractions for you. It provides you your objects that you pass into Redis in the format that you expect them in, which is your domain objects. And it allows you to use them kind of nicely and cleanly. And the last thing I really kind of want to show off here about this library is the way that you can do aggregations with it. So if I want to do those aggregations that I referred to earlier, I can basically just pull out aggregation. That was not a Freudian slip. That was because the D and the V are relatively close to each other on the keyboard. Aggregation set equals provider dot aggregation set employee. And I'm pretty sure I spelled aggregation wrong. There we go. And now I can build these pipelines in my app using just the aggregation set. So I can take this aggregation set and I can, again, iterate over it. So aggregation set dot I don't have to pass an aware clause here because I'm just going to do an apply. And the function that I'm going to apply in here is the function I was talking about before. So say I wanted to take all the employees' sales. I would take the record shell. And the funny thing about aggregations in Redis is they don't return the objects to you. They return whatever the thing in the pipeline is to you. So the trick here is that we want to use this record shell here because this record shell is just a null instance of the object that the aggregation set is using to basically sub in for the type for you. So you know what's actually loaded in the pipeline. And so I can do a record shell dot sales times x dot record shell dot sales adjustment. And then I just have to pass in the name of the alias that I want to use in the output object. So I'll pass in adjusted sales. And now with that done, basically all I need to do is change this to adjusted sales. Adjusted sales, and I mean, I guess we probably shouldn't call this an employee anymore, but it's really just an aggregation result. But I'm going to take the employee and I'll pull out this adjusted sales result from here. And basically all you need to do to access that is access it through a dictionary. And you use the employee you use this aggregation result as a dictionary, and you just do a .NET run, and that'll actually compute the adjusted sales for all of our employees. So this first employee, I guess I could probably do that a little bit nicer, but this first employee here is me with $10 million in sales, but I have a sales adjustment of 0.8, so my sales get adjusted down by a factor of 0.8, and it produces this nice little 8 million result for me. And you can do that with the rest of your objects too. And not only that, if I wanted to apply this sales adjustment here, let me put this on a new line so it's a little bit easier to see. And I want to take this sales adjustment and I want to do something with it further down the pipeline. I can do that too by basically, I can use the sales adjustment in other apply functions, or I could do something useful like grouping all of my records together by their department, for example. So group by x dot record shell dot department, and then I can take those departments and I can compute the average sales for them. By taking that again and passing in the adjusted sales here as a thing that I want to actually perform this reduction on. So I could take all of my employees, I can group them by the departments, I could then average their sales, and then I can order my departments by this average. And then I think I should be able to just say and then I think that should do the trick. And basically what this did now is it took all of my employee sales, it averaged all of my different department sales, then it ordered them descendingly. So you can now you could take these objects that you've inserted into Redis which is just a key value store, right? Everyone thinks of Redis as just a key value store. I can query things now, I can index them, and I could do all sorts of neat things with them, like this right here, where basically we're just computing this random fact about the documents that I have stored in Redis, something you never would have thought you'd be able to do before. You're just able to do with Redis OM and RediSearch. So, I guess we're towards the end of our time, and I want to leave time for some questions if anybody has any. But before I go, I just want to tell you a little bit more about me. I'm Steve, again. I'm a developer advocate at Redis. You can follow me on Twitter or GitHub, or you can find my website at lorello.com. Some resources for this talk. Redis.io is basically the hub now for all things Redis, including RediSearch. There's a part of Redis.io that has some RediSearch stuff in it. The RediSearch Docker image is available on hub.docker.com/redislab/RediSearch. Redis OM is the library that I built, is available at github.com/redis OM NET. And the slides are also up in SlideShare. And if anybody wants to learn more about Redis, we have this great website called university.redis.com, where we basically offer free classes for anybody who wants to learn more about Redis. Or you could find us all in Discord, discord.gg/Redis. And really, if you have any Redis questions at all, you can pop in there and just ask us. So that's about it. Does anybody have any questions?
For the searching you were doing, you were just searching for Steve or Guy.
Yeah.
But what if I never know exactly what I'm searching for? And what if I just search for St?
So there's actually...
So partials, wildcards,
yeah, so
things I might need in a full text search engine.
Yeah, so if you want to do full text search in Redis with RediSearch, and that's actually something, you know what? I don't know why I didn't do it, but I can declare an object. I could declare a field in Redis as searchable, and I'll just say like a personal statement or something like that, and I think I misspelled statement. But I'll just say that my personal statement is that I'm a developer advocate at Redis. And then all I would need to do is try to match that. So for employee in collection.where x.personal statement equals Redis. Then I can just print out employee.name. And you'll see that it printed out for me. And so there's basically two types of indexes that you could build, and I can't believe I didn't say that earlier, but there's indexed and searchable. And searchable basically enables full text search for you in Redis Search. For index, that creates the more exact type matches and numerics and geo. Answer it?
Yes.
Awesome. Anybody else? All right. Well, thank you very much. Thank you for coming. Thank you for coming back from the pub or wherever you were after the evacuation before. I really appreciate you all coming out.